Okay, good morning, class. So, welcome to the last chapter included in our prelim examination. So, we will be discussing today the chapter 3, which is all about carbohydrates or our sugars. Okay, so we will be dividing this chapter into two parts. The first part will be included in the prelim exam, and then the second part will be tackled on our midterm. Okay, so hatiin natin siya sa dalawang parts since medyo mahaba ang carbohydrates. Okay, so let us start with the discussion. So when you say carbohydrates, class, this is actually the most abundant, okay, organic chemical in the world. It is organic. It is a type of an organic chemical. Why? Because your carbohydrates, meron silang carbon in their molecular formula. So they are organic chemicals which are the most abundant in the world. So hindi mga petroleum products, not plastics, or your drugs. Okay, hindi yan sila ang pinaka-abundant. It is actually your carbohydrates. So why is your carbohydrate so important in the world? Saan ba natin ginagamit? What is the purpose of carbohydrates in this earth? So we will know all about that in this chapter. So again, carbohydrates, most abundant organic chemical in the world because, yan, especially your cellulose. So, ang cellulose ninyo, usually these are seen in the parts of your plants. Okay? There are 10 billion tons of cellulose produced daily in the biosphere. Okay? The California redwoods stretch out hundreds of feet towards the sky, and a Brazil nut hard to crack due to aggregates of cellulose. So, 'di ba? Ang two examples na nauna natin, they are both plants. When you say California redwoods, ano ito no? A type of tree that you can only find or growing in California, and it is used in many buildings, so producing buildings and other household materials such as your tables. So, ginagamit siya usually because it is known for its strength. Okay? And then another one is your Brazil nut. Okay? Napakatigas ng nut na ito. That's why ginamit siyang example because again, your cellulose, one function niya is for building material. Okay? So there are other products of cellulose such as the papers you are using and the cotton in your clothing. So you can find cellulose everywhere. You can find it in your clothes and you can find it in your notebooks or your bond papers. Carbohydrates also provide us our roofs, sticks postal stamps to the letters. So pwede siyang paano no? You can use your cellulose to produce glue and basic diets for all of us. So, hindi lang siya building material. It is also used for our clothing, to build houses, and also to make, they call this certain types of glue, and nakakain din siya. It is actually included. Carbohydrate is very important to humans and other living organisms such as your animals because it is used as an energy yielding type of biomolecule. So included siya sa diet natin to give energy, okay, to living organisms. And it is also biodegradable. It can also be used to produce biodegradable trash bags. Okay? It is made up of elements such as your carbon, hydrogen, and oxygen. So there are only three. Okay? Meron lang tatlong elements na makikita sa molecular formula or chemical formula of your carbohydrates. Merong carbon, hydrogen, and oxygen. So tatlo lang. Very simple, but it can produce a very important biomolecule. Okay, carbohydrate is the first class of biomolecules. The name carbohydrate were given by your French scientists who call them as hydrates de carbone. Meaning, Ayan, because of their empirical formula, which is composed of your carbon times your water molecule enclosed and open and close parenthesis, tapos maliit na n. So that this means that any number or any number value na nakalagay dyan sa n, ita-times mo siya sa mga elements na nasa loob. So for example, 2 ang nasa labas, okay? Times mo ang carbon ng 2, times mo ang times mo ang H2 ng number 2 rin, and multiply also your oxygen with number 2, you will get C2H4O2. So, ganyan ang kanyang empirical formula. This is how you will get your empirical formula of carbohydrates. Yan. So, di ba? Hydrates the carbon, meaning a carbon that is hydrated by water. So, yan yung pinakauna niyang name. And then, it was translated to English, naging carbohydrates na. Okay? It was found later that not all carbohydrates follow this formula. So, generally, class, this is the formula for your carbohydrates, but not all carbohydrates will be using exactly this formula. One example natin dyan, which means that they are not simply hydrated carbon, but a more complex substance having 3 to thousands of carbon atoms. Okay. So, since macromolecule ang carbohydrates ninyo, okay, pwede siyang magkaroon ng single to thousands of carbon atoms or chains of carbon atoms. So, ano ba yung types ng carbohydrates natin? You can classify them as polyhydroxyaldehydes, pwede ring polyhydroxyketones, or substances that will yield these compounds when hydrolyzed. So, meron tayong 3 main classification of your carbohydrates. Polyhydroxyaldehydes. When you say polyhydroxy class, meaning when you look at their structural formula, they contain multiple hydroxide ions. Again, ano yung hydroxide ions natin? The OH negative or the OH. Simply the OH. Your hydroxide ions, you can find multiple hydroxide ions within the structure of your carbohydrates. Kaya nga polyhydroxy, meaning many hydroxide ions. Okay? When you say aldehyde, makikita nyo mamaya kung ano yung structure ng aldehyde. But when you say aldehyde, meron siyang CHO sa kanyang structure. And when you say ketone naman, meron siyang carbon double bonded with an oxygen. So you will see later kung anong itsura niyan in the structure, no? So polyhydroxyaldehydes, the first type, polyhydroxyketone, the second type, and any substance that will yield any aldehyde and ketones when hydrolyzed or placed in water. Okay? So that is the introduction. So I will just give you, class, an example of the carbohydrates that are not following the empirical formula, the general empirical formula for carbohydrates. So, tingnan natin, 'di ba? Sabi niya, not all carbohydrates are following the CH2O and formula. One example for that is your rhamnose, RHAMNOSE. Ang rhamnose natin, ang kanyang molecular formula is C6H12O5. C6H12O5. So, 'di ba? It is not following this formula. Kasi hindi walang ratio yung kanyang numbers of elements. 6, 12, and 5. Dapat, diba, 6, 12, and 6, correct? Para sa glucose. Pero ang rhamnose natin, there are only 5 oxygens. So, it is not following this general formula. Another example is your deoxyribose. Okay, do you still remember? Ang kanyang formula is C5H10O4. C5H10O4. So, diba, hindi yung kanyang ratio is not balanced. As in, meron kang 5 carbon atoms. You also have 10 hydrogen atoms but only 4 oxygen atoms. So again, not following the given formula in here. So those two are the examples that carbohydrates are not just hydrated carbons. They are more complex than this description. Hydrates the carbon. Okay? What else? Okay. Yielding. Okay, 1, 2, 3 principles classes. Sige, let's proceed. Learning outcomes natin for this chapter. You will be able to discuss the important role of carbohydrates in the body. At the end of the chapter, dapat alam na ninyo kung para saan ang carbohydrates. What is the function of your carbohydrates in the body? Number 2, you will be able to demonstrate the similarities and differences of the classes of carbohydrates. Dapat mapaghiwalay-hiwalay ninyo or differentiate the different classes of your carbohydrates. Number 3, you will be able to evaluate the name and the structure of a carbohydrate. So, pwede na kayong magbigay, no? Naming the carbohydrates. Number 4, you will be able to explain mutant rotation and how it will happen. Number 5, you will be able to give the diagram of the cyclization of monosaccharides that lead to the formation of furan and pyran rings. And then number 6, differentiate the structures of disaccharides. Because your disaccharides have multiple types of structures, you will be able to write these structures at the end of the chapter. And number 7, discuss the importance of your sweeteners and diet. So ito siya class, ito siguro sa midterm na from 7 to 10. Midterm nyo na ito siya madidiscuss. Or we will discuss this on the first part of our midterm. Sige. Okay, let's start with the role of carbohydrates. When you say role of carbohydrates, this is the importance of your carbohydrates. Okay? Carbohydrates are aldehyde or ketone compounds with many hydroxyl groups. So again, aldehyde and ketone, nabanggit na naman. Ayan o, many hydroxyl groups, meaning, kaya siya tinawag na polyhydroxyaldehyde and polyhydroxyketone because again, it contains multiple OH bonds in it. They make up most of organic matter on Earth because their extensive roles in all forms of life. So, most of the living things that are found in Earth class will be consuming or will be producing carbohydrates. Producing, for example, your plants, they are able to produce carbohydrates. And for humans, we are able to consume carbohydrates from different types of food and plants. Okay? First role of your carbohydrate. Carbohydrates serve as a storage of energy, fuel, and metabolic intermediate. They are very effective energy yielding nutrients. So again, main function of your carbohydrate is to provide energy for the living system. Okay? Yung kanyang chains of carbon atoms actually holds a huge amount of energy. Kaya pwede siyang magamit as fuels, okay? And your carbohydrates can also be used as metabolic intermediates, meaning it can be used to transport sugar, monosaccharides itself. Okay? So, paano nakakarating yung sugars in the different parts of the body? Okay? So, yan yung i-discuss natin later. Okay. It can provide biological energy based on the following criteria. So, how will your carbohydrates provide biological energy? When you say biological energy, the energy that can be directly used by your living systems, okay? Or yung direct na ginagamit ng katawan mo. So, how will a molecule be considered as energy yielding or biological energy yielding molecule? Ito yung mga criteria niya. Number 1, a molecule must contain carbon of about 40% by mass on average carbohydrate. Before makonsider as biological energy yielding yung isang molecule, dapat 40% ng kanyang mass is composed of carbon. Ang isang carbohydrate, makakapag-provide lang siya ng energy for the body if 40% ng kanyang structure is composed of carbon atoms. Okay? Second, in the criteria, it is relatively reactive. Dapat ang carbohydrate, before it can be considered as energy yielding, the carbohydrate must be reactive. Meaning, it must contain many polar bonds. When you say polar bonds, class, your polar bond exists whenever atoms with different electronegativities will share electrons in a covalent bond. Okay, so dapat before nangyayari lang ang polar bonds kapag there is sharing of electronegativities between the atoms found in the molecule or the structure of the molecule. So dapat maraming polar covalent bonds yung structure ng carbohydrate. Dapat nagkakaroon ng sharing of electronegativities between the atoms found in the structure of your carbohydrate in order to produce a polar bond. So kapag may presence ng polar bond or polar covalent bond, meron ring reactivity ang inyong molecule. Ulitin ko ha. In order for a carbohydrate to become reactive, dapat meron siyang polar bonds. And your polar bonds will only occur if nagkakaroon ng sharing of electrons or electronegativities ang atoms within the structure of your carbohydrate. Okay? The third in the criteria, in order for a molecule to be considered as effective energy yielding molecule, is it must contain carbons that have less than 4 bonds to oxygen which may be oxidized further. So dapat hindi lalampas sa 3 oxygen ang naka-attach doon sa structure ng carbohydrate mo in order for it to yield energy. Nakuha? Ayan, dapat less than 4 bonds of oxygen. So dapat hindi lalampas sa 3 ang oxygen na makikita sa structure ng inyong carbohydrates. Okay? Those are the 3 criteria bago makonsider ang isang carbohydrate as energy yielding. Kasi baka isipin ninyo, kapag sinabing carbohydrate, lahat sila is energy yielding, which is wrong. Mali yan siya. Hindi lahat ng carbohydrates class ay nagbibigay ng energy sa mga living organisms. Dapat ma-follow muna ng carbohydrates itong 3 criteria na ito before it can be considered as energy yielding. Okay? I hope you are holding your course pack. Dapat hawak na ninyo ang course pack ninyo, and then while I am talking, jot down the important informations I am talking about. This is how you will study biochemistry. So, always take down notes kasi most of the quizzes that I will be giving are coming from the words and informations I am telling you during the discussion, the video discussion. Okay? So, ayan. I-take down ang mga notes. Highlight ang mga dapat i-highlight sa course pack. Okay? So, that is the first example of the role of the carbohydrate. Okay? Ang first example natin ng kanyang role is it is an important energy yielding molecule. Or it can also serve as energy storage. Sige. Let's go to the second importance of your carbohydrate. Your carbohydrates are also part of the genetic material. Okay, another important role niya, it composes the genetic materials of living organisms. Nakikita siya sa RNA and sa DNA. So saan siya doon? Yung sugar found in the structure of your RNA and DNA, which is the ribose and your deoxyribose. So both sugars will form the structural framework of your RNA and DNA. So 'di ba? Hindi lang siya para sa hindi ang carbohydrates natin hindi lang para building of materials or providing energy for our body. It is also used for heredity, okay? Or preservation of genetic materials. If wala tayong ribose and deoxyribose, the structure of your DNA and RNA will not be complete. So, carbohydrates play a very wide role in our lives. Number 3, okay, the third example of the role of carbohydrate is the involving the polysaccharides. Your polysaccharides class are structural elements in the cell walls of bacteria and plants. So, ginagamit sila, the polysaccharides are used as as a protection for the cells of your bacteria and plants. Okay, for support, protection, and structural or building material for its cell walls. Okay, so polysaccharides natin composed of many monosaccharide units. Sige, discuss lang natin yan later. In fact, your cellulose is an example of a polysaccharide, by the way. Your cellulose, the main constituent of plant cell walls, is one of the most abundant organic compound in the biosphere. So, sikat na sikat yung cellulose natin, and it is usually found in the cell walls of your plants. Pag sinabing cellulose, sa plant yan siya makita. Okay? Carbohydrates can serve as very effective building materials. So, ayan ang pang third natin. Polysaccharides of your carbohydrates can be used as an effective building material. Number 4, your carbohydrates are linked to many proteins and lipids where they play key roles in mediating interactions among cells and interactions between cells and other elements in the cellular environment. So, sabi ko nga kanina, your carbohydrates can be used as transportation. Since your carbohydrates class are very reactive, 'di ba? Tama. Reactive siya kasi nga meron siyang mga polar bonds. So, meaning, pwede siyang tumanggap ng other molecules inside our body in order to transport, okay, those molecules to different parts of the body. That's why, mediating interactions. It mediates interactions among and between the different cells within your body. Para siyang messenger. Ginagamit siyang messenger ng mga cells that are found inside the body. Because, again, it is very reactive. And it can attach to many different types of molecules. Ayan, so cellular environment. So when you say cellular environment, yun nga, this involves the interactions between your cells. A key related property of carbohydrates in their role as mediators of cellular interaction is the tremendous structural diversity possible within their molecules. Besides, they are very reactive, they are also very diverse when it comes to the structural or the structure of your carbohydrates. Since ang range ng structural differences within your carbohydrates class is very wide, pwede siyang magkaroon ng maraming differences in structural form depending on the type of the carbohydrate. pwede siyang magamit as mediator in many reactions within or between, okay, the interactions of your cells. Okay? So those are the roles of your carbohydrates. Now, let's go to the classification of carbohydrates. Ano ba yung iba't ibang types ng carbohydrates? How will we classify them? Okay? Okay, sige. Before we will proceed, i-summarize muna natin yung role of carbohydrates. So, meron tayong 4, di ba? The first one is energy-yielding nutrients. They are used for energy, or they are used for yielding energy for the body of living organisms. Okay, the second role is framework for, it provides, or your carbohydrates provides framework for RNA and DNA structure. The third role is they are effective building blocks. And then number 4, your carbohydrates are used in the mediation of the interactions between your cells or in cellular environment. So, yan ang 4 natin na roles of carbohydrates. Let's proceed with the classification of carbohydrates. Your carbohydrate can be classified depending on the number of the monosaccharide or sugar units linked to the molecule. So, ito yung 4 natin, no? Kung kanina, ang classification natin is based on the presence of aldehyde group and ketone group. Ito naman, this classification is based on the number of monosaccharide units found in the carbohydrate. So, number 1, okay, is your monosaccharide. Your monosaccharide class, this is the primary unit of your carbohydrates. When you say primary unit, it cannot be into simpler carbohydrate units. So, hindi mo na ito siya ma-break down into smaller units. Siya na ang pinakamaliit na unit ng carbohydrate. You have your monosaccharide. It is the basic carbohydrate unit of cellular metabolism. So, most of your monosaccharide class, ito sila ang ginagamit ng body natin in absorbing energy. Okay? So, ito sila ang readily absorbed by the body, monosaccharides. When you say disaccharides, oligosaccharides, and polysaccharides, ito sila, hindi sila readily absorbed by the body. Okay? Meaning, hindi sila nagagamit agad-agad for energy yielding. Dapat ma-convert na ito into monosaccharides before the body will be able to use the energy. Okay, so monosaccharide is the basic carbohydrate unit of cellular metabolism. Monosaccharides lang ang nagagamit for energy when it comes to cellular metabolism. Okay, you have 3 examples of your monosaccharides. You have the GGF. Okay, so gamitin niyang GGF para matandaan ano yung mga examples ng monosaccharides. When you say GGF, it stands for glucose, galactose, and fructose. Okay? Ito sila ang mga primary sugars of carbohydrates. Okay, number 2, you have your disaccharide. From the word itself, di meaning 2. Meaning, it is composed of 2 monosaccharide units. Okay? Yung dalawang monosaccharide units na component ng disaccharides, they can be the same monosaccharide or pwede different monosaccharides. So, pwedeng glucose lang, parehong units ng monosaccharides. Pwede rin your disaccharide is composed of different monosaccharides such as glucose plus galactose. Okay? So, pwedeng pareho component na monosaccharide, pwede ring magkaiba. Okay. So, yan it will yield 2 monosaccharide units when hydrolyzed, or when your disaccharides react with water, with an acid, or an enzyme, it will yield or produce 2 monosaccharide units. Okay? Often, your disaccharides are used by your plants or animals to transport monosaccharides from one cell to another. So, usually, ang function of disaccharides is to transport your monosaccharide units to different cells in the body. Okay. So, sa disaccharides, ano ang meron tayo? SML. Ang example niya, SML, which stands for sucrose, maltose, and lactose. Okay? Sige. Number 3, you have your oligosaccharides. Your oligosaccharides class, they are still considered as small. Kasi nga, small, ano pa siya, no? Small carbohydrate pa siya because it is only composed of 2 to 6 monosaccharide units. So, maliit pa rin yan siya compared to your polysaccharides. Okay? So again, oligosaccharides made up of 2 to 6 monosaccharide units linked together. When you say oligo, this comes from the Greek word oligos, which means small or few. Okay? So, usually class, wala ka masyadong makikita na oligosaccharides in the natural environment, no? They are not that, they are not that prevalent in the natural environment. Wala ka masyadong makita na ganito inside the body. Okay, number 4, you have your polysaccharides. Coming from its name, poly, meaning more than or many units or composed of many units of monosaccharides. So, your polysaccharide class is considered as a macromolecule or macromolecular substance because it is composed of many chains of carbon atoms or it is composed of many chains of monosaccharides. Napakarami niyang monosaccharide units. Okay? So that means that when your polysaccharide is being hydrolyzed by either water with acid or enzyme, it will produce many monosaccharide units. So we have here the examples of substances considered as polysaccharide. Number 1, you have your starch. Second, you have your glycogen. And third, you have your cellulose. Okay? So, SGC yan sila. SGC. Don't forget. Okay? So, ito sila classification based on the number of monosaccharide units. Furthermore, let us classify the different types of your monosaccharide. So, if may classification ka ng carbohydrates, meron ka ring different classifications for your monosaccharides. Ayan, no? A monosaccharide is classified on different ways. So, ilang ways na pwede mo maklasify ang monosaccharides? 1, 2, 3, 4, 5, and 6. So, meron kang 6 ways to classify your monosaccharide. So, we will just familiarize this. The first way to classify your monosaccharide is based on the number of carbon atoms. Ilang carbon atoms ang makikita doon sa structure ng monosaccharide. So, number 1, or letter A, you have your triose. When you say triose, it is composed of 3 carbon atoms. So, ang kanyang empirical formula is C3H6O3. Okay? So, this is following the general formula for carbohydrates. How about a monosaccharide composed of 4 carbon units? You call that as tetrose with the formula C4H8O4. And a monosaccharide composed of 5 carbon unit is called pentose, C5H10O5. And then, a monosaccharide composed of 6 carbon atoms is called a hexose with the formula C6H12O6. And lastly, you have your heptose composed of 7 carbon atoms. So, C7H14O7. So, ito siya ang first classification of your monosaccharides based on the number of carbon atoms. The second classification of your monosaccharides is based on the functional group found in the structure. Ito na yung aldose and ketose. Okay, functional group, especially the carbonyl group. Okay. So when you say carbonyl group class, ang carbonyl group, ito na siya. Carbon double bonded to an oxygen. Ako ha, yan ang carbonyl group. C double bond to O or carbon double bonded to an oxygen atom. So pareho sila. The aldose and the ketose will contain, both of them in their structure will contain a carbonyl group. Saan lang sila nagkaiba? In the position of the carbonyl group. Okay? So magkaiba lang yung ating aldose and ketose, okay, in the attachment of the carbonyl group within the structure. Your aldose, okay, it is considered an aldose when your carbonyl group is present and attached to carbon number 1. Makikita ang inyong carbonyl group sa carbon number 1. Okay? So, a carbonyl group that is found in carbon number 1 is called aldehyde group. Nakuha? Again, ulitin ko. A carbonyl group that is attached to the first carbon in the structure of a monosaccharide is called an aldehyde group. Ano ang itsura ng aldehyde group? Ayan o. Ito ang kanyang structure. C double bonded to oxygen and single bonded to hydrogen. So, pwedeng CHO. Para mas madali, no? Tandaan ninyo. When you say aldehyde group, okay, your aldehyde group is present in the structure of an aldose monosaccharide. Okay, makikita ang aldehyde group sa structure ng aldose monosaccharide. And ano ang kanyang structure? CHO, a carbon single bonded to hydrogen and double bonded to an oxygen. Yan ang aldehyde group. Let's go to the ketose. Ang ketose naman natin, class, ang kanyang carbon atom, ang kanyang carbonyl group, eto, C double bond O, will be attached to carbon number 2. So, sa second carbon mo, makikita yung carbonyl group. Now, if a carbonyl group is attached to carbon number 2, the structure is called ketone group. Nakuha? Ketone group kapag ang carbonyl group mo is found on the second carbon. So, when there is a presence of ketone group, the monosaccharide is considered as a ketose. So, don't worry, makikita nyo later ang pinagkaiba ng aldose and ketose. Okay, so that is the second classification of your monosaccharide, either aldose siya or ketose siya, based on the position of the carbonyl group on the structure. The third classification of your monosaccharide is based on the spatial orientation of the hydrogen and hydroxide groups attached to the carbon adjacent to the terminal primary alcohol group. So, ano ba yung terminal primary alcohol group? When you say terminal primary alcohol group, class, ito yung CH2OH. Ayan siya ha, CH2OH. This is an alcohol group. Kasi, they call this combination siya ng isang alkyl group at hydroxide ion. So, yan ang mga alcohol group natin. Meron siyang, they call this alkyl group, carbon that is bonded to hydrogen ions, and meron din siyang hydroxide in its structure. So, alkyl plus hydroxide group will form your alcohol group. So, bakit tinawag na terminal primary yung alcohol group? Kasi makikita siya sa primary carbon. Diba? I already explained to you what a primary carbon is. 'Diba, ang primary carbon atom natin is found sa pinaka dulo ng structure, and it is bonded to only one carbon atom. So dito sa structure na ito, saan dito primary carbon atom? 'Diba? Carbon na nasa pinakataas and carbon na nasa pinakababa. So both of these are considered as primary carbon atoms. Kaya primary alcohol group. Kasi yung alcohol group mo is nasa primary position. Okay? And then terminal, ganun din kasi nasa pinakadulo siya. Okay? So kapag sinabi mong terminal primary alcohol group, nasa pinakababa. Yung carbon na nasa pinakababa and bonded to hydrogen ions and hydroxide ions. Okay? So sabi niya dito, we are classifying the monosaccharide based on the position of the hydrogen and hydroxide groups attached to the carbon adjacent to the terminal primary alcohol group. So meaning, if ito ang terminal primary alcohol group, the carbon adjacent to it is the second. Second carbon. A carbon that is adjacent to your alcohol group is the one on the top of your terminal primary alcohol group. So, ito siya. So, tingnan mo daw yung carbon sa taas ng alcohol group. Na ano ang position ng hydrogen and hydroxide group na naka-attach sa kanya. It can either be a D isomer or L isomer. Sige, let's discuss. What is a D isomer? When you say D isomer, class, your monosaccharide is considered as a D isomer when the hydroxide group is written to the right of the carbon adjacent to your terminal primary alcohol group. So, kung tingnan natin dito, is this a D isomer or an L isomer? This is a D isomer because yung hydroxide group found in the carbon number 2 is attached to the right. Okay? So, ito siya, D monosaccharide ito siya or D isomer. Kuha? Ano naman ang L isomer? When the hydroxide group is written to the left, okay, in the projection formula. So, kung tingnan mo ang carbon na adjacent sa alcohol group natin, ang position ng kanyang hydroxide group is makikita sa left side. So, this one is considered an L isomer. Okay? So, ang ginamit dito na example is your glyceraldehyde. So, when you say glyceraldehyde, class, ito siya ang pinaka-simple. Okay? The simplest monosaccharide. Kasi nga, only composed of 3 carbon atoms. So, ang tawag mo sa isomer na ito is glyceraldehyde or tawag mo sa molecule na ito is glyceraldehyde. Bakit glyceraldehyde siya? Tingnan nyo, may aldehyde. 'Di ba? So, meaning, isa siyang aldose. Meron siyang aldehyde group in the structure. So, if you will see here, meron ba siyang CHO? Meron. On the first carbon atom, sa pinaka-top na carbon atom, you will find the aldehyde group CHO or carbon double bonded to oxygen and single bonded to hydrogen. So, we will classify this as an aldose. Okay? So, ito ang ating glyceraldehyde. Meaning, this is the simplest type of monosaccharide composed of only 3 carbon atoms. Okay, so ang kanyang empirical formula is this one, C3H6O3. Kasi ito na ang pinaka-simple natin na monosaccharide. Monosaccharide composed of 3 carbon atoms. So, ang pangalan niya is glyceraldehyde and kinonsider siya as glyceraldehyde kasi nga meron siyang aldehyde group sa kanyang top, pinaka-top na carbon atom. Okay? So, ito ang L-glyceraldehyde kasi ang kanyang OH group is found on the left. And ito naman ang D-glyceraldehyde because its OH group is found on the right. So, I hope naintindihan. Sige. So, wala para na-include ba dito ang ating I will show you a structure of a dihydroxyacetone naman. Sige class, wait lang ha. I will attach the picture na lang para makita ninyo. Okay, is this recording? Ayan. So, ipakita ko sa inyo ang difference ng isang ketose and aldose. We have here the two simplest types of monosaccharides. You have pareho sila ng chemical formula actually, or empirical formula. You have your glyceraldehyde and your dihydroxyacetone. I hope this is recording. Yan. Okay? So, pareho silang dalawa. These two are considered as the simplest monosaccharides kasi nga tatlo lang ang kanilang carbon atom. Meaning sila ay triose. Okay? Triose or triose. Only have 3 carbon atoms in the structure. So, may 2 types tayo. Ang isa is aldotriose with an aldehyde group, okay, on carbon number 1. And we also have ketotriose, meaning keto siya, which have keto group in the second carbon atom. Kita nyo ang difference niya, di ba? Sabi kanina, sa aldose and ketose natin, ang aldehyde group, makikita ang CHO sa primary or sa ating carbon number 1. Sa keto group naman, makikita ang C-double-bond-2O on the second carbon atom. Now, you call these two simplest, ang pangalan nila glyceraldehyde, ang isa naman is dihydroxyacetone. So, aldotriose ang glyceraldehyde, ketotriose naman ang ating dihydroxyacetone. So, why am I showing you this? Para maklasify ninyo kasi later on, pwede kayong ipasulat ng structure ng aldose, pwede rin kayong ipapasulat ng structure ng isang ketose. So, at least, malaman ninyo yung pinaka-simplest form nila. Okay? So, let us go back. Okay. The D and L do not refer, balik tayo dito ha, sa D isomer and L isomer. When you say D isomer and L isomer, this does not refer to the direction of optical rotation. So, hindi ibig sabihin na kapag D isomer siya, i-rotate niya ang ating polarized light into right, and then hindi ibig sabihin na pag L siya, i-rotate niya to the left. No. The L and the D does not involve the rotation of your plane polarized light. However, the D and the L forms of any specific compound are enantiomers. Okay, meaning ang D and L isomer natin, they are both enantiomers, meaning they are mirror images of each other. For example, you have your D and L glucose. The D-glucose is the mirror image of the L-glucose and the L-glucose is the mirror image of the D-glucose. Diba? Kung tingnan mo, lagyan mo siya ng plane dito sa gitna. They are both mirror images of each other. Nagkakaiba lang sila sa position of the hydroxide group in their 1, 2, 3, 4 fourth carbon or the carbon adjacent to your alcohol group. So kung tingnan mo, D-glucose siya. Why? The hydroxide group is found on the right of the carbon adjacent to your alcohol group. L-glucose naman ito kasi ang kanyang hydroxide group is attached, okay, to the left side of your carbon adjacent to your alcohol group. Nakuha? So, hindi ito sila magkaiba. I mean, yung D and L are not referring to the rotation of plane or the direction of the rotation of the plane polarized light. Hindi ibig sabihin ito right, ito left. No. It's only showing that your D isomer and your L isomer are enantiomers. They are both mirror images of each other. Okay? Looking at the structure of your D-glucose, the OH is at the right on the carbon after the terminal primary alcohol, and its mirror image is N-glucose, in which the OH group is at the left, okay, of the carbon after the terminal primary alcohol. I hope that is clear. Sige. So, talking about the rotation of the plane polarized light, ito na siya. Okay? The positive and the negative isomer. Ito na ang sign. So, meaning, hindi letters ang pagbabasihan mo sa direction ng pag-rotate ng plane polarized light. You will base it on the positive and negative sign. Nakuha? Kapag, ayan, based on the rotation of the monosaccharide on the plane polarized light, those monosaccharides that will rotate your plane polarized light to the right has a symbol of positive. Okay? And monosaccharides that will rotate the polarized light or the plane of the polarized light to the left has a negative sign. Okay? So, for example, nakita niyo dito, for example, ito. Meron siyang ganito sa unahan niya. Sandali lang. For example, may positive dito. Yan. So, ito siya, positive D-glucose. Meaning, isa siyang D-isomer of glucose that rotates the plane of polarized light to the right. Kuha? Paano naman kapag ganito? Ayan. May sign siya. Ito naman, meaning this glucose is an L-isomer that rotates the plane of polarized light to the left. So, ganyan siya ha. So, ibahin natin, magkaiba ang positive and negative sign sa letter D and L na classification. I hope you remember that. Okay. Let's proceed to number 4. Number 5 na pala. You can also classify your monosaccharides class based on the ring or cyclic structure. Okay? Yung sa kanyang ring na makikita sa structure ng monosaccharide. So, pwedeng furanose ang monosaccharide if it contains a 5-membered ring. Meaning, 5 corners ang makita mo sa ring niya. 1, 2, 3, 4, 5. Okay? 5 ring structure taken from furan ring compound. Ayan. So, ito ang compound natin. So, any monosaccharide that will contain a furan ring structure is called furanose. Kuha? 5-member ring siya, but the ring actually contains only 4 carbon atoms. 1, 2, 3, 4. So, furan, coming from the word 4, it contains 4 carbon atoms. Furan. Okay? Pero 5-membered ring siya kasi meron pa siyang oxygen. Let's go to pyranose. So your pyranose class, this is a monosaccharide containing a 6-membered ring structure coming from the pyran ring compound. So this is our pyran ring compound. Okay, meron siyang 6 na quarters. 1, 2, 3, 4, 5, 6. So 6-membered ring structure ang pyran natin, but it only contains 1, 2, 3, 4, and 5 carbon atoms. So, pyran containing 5 carbon atoms and 1 oxygen and 6 hydrogen atoms. So, any monosaccharide that will contain the pyran ring structure is called pyranose. Okay, number 6. Based on the orientation of the hydrogen and hydroxide groups attached on the chiral carbon atom in the cyclic structure of monosaccharides. So, pwede tayong magkaroon ng alpha A configuration. Pwede rin ang inyong monosaccharide will be considered as a beta configuration. Depending doon sa posisyon ng kanyang hydroxide group in the ring structure. Sige ha, tingnan natin. Your alpha configuration happens when the hydroxide group is located below the ring structure. For example, gamitin natin itong ring structure ng furan. Okay? You will consider the monosaccharide as alpha configuration kapag ang OH group niya makikita sa taas. Okay? So, dito, banda, makita mo sa taas. So, if lagyan mo siya ng linya dito, makita mo sa above the ring. Below the ring of the structure. Ako ha. So, kapag nasa baba ang hydroxide group, you will consider that as alpha configuration. Below the ring. Kapag beta naman, you will see the hydroxide group above the ring structure. Anyway, sige, hanapan ko kayo ng picture niyan. Sandali lang. Okay, we're back. These are the difference between your alpha configuration and beta configuration. So, you consider it as an alpha glucose. Ito siya, ang molecule na ito class is glucose ha. So, considered as alpha glucose siya. Why? Because the hydroxyl group is found below the ring. Diba? Nasa baba siya ng ring. Pero, you will consider it as beta glucose if the hydroxyl group is found above the ring. Okay? Pag nasa baba ng ring, hydroxyl group. Kapag nasa taas ng ring, ang hydroxyl group, beta glucose siya. Kapag nasa baba, alpha glucose. So, beta and alpha configuration. Yan ang pinagkaiba nila. Okay? Where are we? Okay. Sige, ito. Siguro sa activity nyo na lang ito, no? Ipagawa ko sa inyo sa activity niyo. For example, write the projection formulas of D-aldotriose, L-ketotriose, and L-aldopentose. So, ito. Examples niya, D-aldotriose. The triose indicates na ang structure ng monosaccharide is only containing 3 carbon atoms. So, yan ang una mong isulat. Carbon, carbon, carbon. 1, 2, 3. The aldo indicates that the compound is an aldehyde, which means that the carbonyl group is on carbon number 1. So, since aldo siya, ang double bond to oxygen will be found on carbon number 1 together with single bond with hydrogen. Okay, so meron ka na top part. The D indicates that the hydroxide group on carbon number 2 or the carbon adjacent to your primary alcohol is on the right. So, dito sa second carbon, since siya ang adjacent sa ating alcohol, you will write the hydroxyl group sa left side. Sa right side. Kasi nga, D isomer siya. And then, hydrogen naman sa left side. And then, lagyan mo na ng alcohol sa baba, CH2OH. You will get the structure of D-aldo triose. Okay? Next, L-keto-tetrose. So, tingnan ang kanyang main name. Tetrose, meaning it is composed of 4 carbon atoms. So, isulat mo na carbon 1 connected to carbon 2 to carbon 3 and carbon 4. Okay? Keto-tetrose siya, meaning the carbonyl group is found on the second carbon. So, lagyan mo ng double bond oxygen ang second carbon. So, anong mangyayari doon sa first carbon natin? Since walang aldehyde group doon, di ba? Nasa second group ang ating carbonyl group. So, nawala yung aldehyde group. If nawala ang aldehyde group, then you will just replace that with another alcohol group. So, yung carbon na CHO for aldehyde group, papalitan mo siya ng CH2OH. Kuha? And the next, L-keto-tetrose siya, meaning ang hydroxide or hydroxyl group mo is makikita on the left side. So, saan ang carbon adjacent to your pinakahuling alcohol group? So, ito, carbon number 3. Therefore, dyan ka magsusulat ng OH on the left side and then hydrogen on the right side. This is the structure of your L-keto-tetrose. How about aldopentose? L-aldopentose. It is composed of 5 carbon atoms. So, isulat mo lang 1, 2, 3, 4, 5 carbon atoms. Aldose siya, meaning may CHO siya sa pinakaunang carbon. So, sulat mo na carbon, double bond to O, single bonded to hydrogen. And then L. Okay, L ang kanyang configuration, meaning the second to the last carbon will have its hydroxyl group on the left side. Okay? So, this is the L-aldopentose. Okay, will you try this by yourself? Sige, ito sa activity na lang. Sa ating activity na lang ito sila. Which will be next meeting? Or on Friday, I think. Or on Thursday, depende. Okay? So, ito yung examples natin ng writing chemical structures. So, naintindihan na ba? Ganito ang writing ng chemical or structural formula. Or projection formula. Pwedeng ibibigay lang ang name sa inyo and then you will write the structure. Pwede rin ibibigay ang structure nyo and then you will write the name. Okay? Sige, let's continue to the explanation of the different monosaccharides. So, explain natin ano yung mga iba't ibang monosaccharides. Sige. Your monosaccharides, there have been many monosaccharides that are synthesized or ginawa in the laboratory. However, only a few have much biological significance. Hindi lahat ng types ng monosaccharides natin in class nagagamit ng katawan. Okay? To mention, your ribose, which is a pentose monosaccharide, meaning a monosaccharide composed of 5 carbons or carbon atoms, and its deoxy derivative are essential in the components of ribonucleic acid, deoxyribonucleic acid, DNA. There are 3 hexose monosaccharides, tatlong monosaccharides with 6 carbon atoms, namely your glucose, galactose, and fructose. So, tatlo lang sila na merong 6 na carbon atoms. Okay, these 3 are the most important carbohydrate sources of cellular energy. Meaning, dito sa tatlo na ito nanggagaling ang energy ng body. Okay? And therefore, they are major significant to nutrition, or very significant sila in the nutrition of the living organisms. These three hexoses have same molecular formula. Pare-pareho lang ang molecular formula ng glucose, galactose, and fructose. Ang formula nila is C6H12O6. And they deliver the same amount of cellular energy. But they differ in their structure. Magkakaiba-iba sila. Pareho sila ng empirical formula, but they differ in their structure. Uha? So therefore, they are biologically interconvertible. Pwede mo silang pagpalit-palitin. Okay? Glucose plays a central role in carbohydrate energy utilization. Other carbohydrates are usually converted to glucose before cellular utilization. So, itong tatlo class, pwede mo silang palit-palitin as long as you will convert galactose and fructose to glucose. Kasi nga, glucose yung ginagamit ng, or glucose is the only one readily used by your cells. So, i-convert mo muna sa glucose yung inyong sugar bago siya ma-absorb ng inyong and magamit ng inyong cells. So, let us talk about glucose, galactose, and fructose. Your glucose is the most important monosaccharide. It is an aldohexose, meaning ang glucose niyo meron siyang carbonyl group in carbon number 1 or meron siyang CHO structure in carbon number 1. Your glucose is usually found in free state in plant and animal tissue. Okay? So, makikita lang siya in the plant and animal tissues. It is also known as dextrose. It is dextrorotatory, meaning it rotates the plane of polarized light to the right. Ang glucose niyo niro-rotate niya ang polarized light to the right. That's why dextrorotatory siya. So, tinawag siyang dextrose. Or, pwede ring grape sugar. Because your glucose is present in grapes, okay? It is component of your disaccharides, sucrose, maltose, and lactose. So, ang glucose natin, lahat ng disaccharides, sucrose, maltose, and lactose, lahat yan meron silang glucose, okay, in their component. It is also the monomer of the polysaccharide starch. So, meron ding glucose sa structure ng ating starch, cellulose, and glycogen. And, ano ang level of sweetness ng glucose? Intermediate sweetness. So, tamang-tama lang. Your glucose is the sugar of the body, which is carried by the bloodstream to all body parts. So, yung sugar na present sa blood ninyo, glucose yan siya. Hindi galactose, hindi rin fructose. Okay? It is normally 8 to 10 milligrams per 100 ml of your blood. It is also called blood sugar because it is the most abundant carbohydrate in your blood. It is given intravenously to patients who cannot take food by the mouth. Okay? Since it will require no digestion. So, hindi na kailangang i-digest itong glucose kasi monosaccharide na nga siya. So, readily na-absorb na siya agad-agad ng cells kahit na walang digestion na nangyayari. Kaya itong glucose ninyo, nakikita siya sa dextrose na binibigay sa mga patients in the hospital that are not able to digest their food. Okay? Or hindi pwedeng kumain. Or hindi nakakakain. Okay. Patients with diabetes mellitus have glucose in their urine and the condition of excreting glucose in urine is called glycosuria. So, kapag may diabetes ka, sure na meron kang glucose present in your urine and you call that as glycosuria. So, kapag tinest ang urine ninyo and merong high level of glucose, meron kang glycosuria which may which may result from having a diabetes, okay? Or diabetes. Next is your galactose. The galactose, it is an aldohexose pa rin. So, meron siyang carbonyl group in carbon number 1. And your galactose found together with your glucose in lactose and in many oligo and polysaccharides, namely your pectin, your gums and mucilages. So, itong pectin, gum, and mucilage class, examples yan sila ng mga polysaccharide. So, ang galactose ninyo, component ng tatlo na yan. Ano ba ang pectin? When you say pectin, this is an acidic structural heteropolysaccharide contained in the middle lamella and cell walls of your terrestrial plant. So, nakikita ang pectin as a component in the cell wall of your terrestrial plants. How about your gum or gums? When you say gum class, this is ginagamit siya in the food industry as an emulsifier. So, ang kanyang origin is coming from natural origin pa rin, so in plants. Okay? So, ginagamit siya as emulsifier. When you say emulsifier, your gums are used for thickening agent. Okay, ginagamit siya as a thickening agent for the production of your chewing gum, pwede rin in the production of your candy and icing. So, pangpatiga siya kasi it has a very large viscosity level kapag nilagay mo siya in solutions. Okay? It increases the viscosity level of your solution. So, yan ang gum or gums. When you say mucilage naman class, this is thick gluey substances produced by nearly all plants, okay, and some microorganisms. So, ginagamit siya usually ng mga protists natin for locomotion. Nagamit rin siya ng ating algae, amoeba, and slime molds, okay. So, any sticky substances produced by plants and microorganisms, mucilage yan sila. So, they are also polysaccharides. And meaning they contain galactose. Okay? Asan na tayo? Your galactose is an isomer of the glucose which differ only in the spatial arrangement of the hydrogen and hydroxide groups in carbon number 4. Pareho sila ng structure ng inyong glucose but they differ in the position of the hydrogen and hydroxyl groups sa carbon number 4. Your galactose is synthesized in the mammary glands to make lactose for milk. It is also a component of your glycolipids and glycoproteins. When you say glycolipids, combination of monosaccharide and your lipid. And glycoprotein, combination naman ng monosaccharide and protein. Okay. It is also a component of your glycolipids and glycoproteins in many cell membranes, especially in the nervous tissue. So, makikita ang galactose class in our nervous tissue. Okay? It is less than half as sweet as glucose. So, if intermediate lang yung sweetness ng ating glucose, sa kanya, mas mababa pa ang sweetness niya. An inherited condition of infants that cannot metabolize galactose is called galactosemia. There are times that newborn babies class are not able to digest galactose coming from the lactose, okay, or the milk they are drinking, okay. So, in this condition, the galactose concentration markedly increases in the blood and appears in the urine. So, since there is a high concentration of your galactose, sumasama na siya sa urine. This causes vomiting, diarrhea, enlargement of the liver, and often mental retardation. Kaya, very dangerous ito for infant kasi pwedeng magkaroon ng problem in the mental capacity of the child kapag nagkaroon siya ng galactosemia. And it can also lead to death if it is not recognized within few days after birth. So, if ang newborn nagkakaroon ng diarrhea and vomiting, okay, please check immediately sa ang kanyang iniinom na gatas or ipa-check agad sa doktor so that you will know if merong problem with with the digestion, okay, of the infant. The symptoms disappear and normal growth may be resumed if the diagnosis is done early and the lactose is excluded in the infant's diet. So, tatanggalin sa diet ng infant yung lactose. Okay? So, these are the structure of your glucose and other aldoses. Emil Hermann Fischer established the structural configuration of glucose along with that of many other sugars. So, siya yung gumawa ng siya yung pinakaunang gumawa ng structural configuration for our monosaccharide, si Emil Fischer. Okay, is this recording? Ayan, so Emil Fischer is the first one to establish the structural configuration of your glucose along with many other sugars. So, he actually received the Nobel Prize in Chemistry in 1902 because of his work. He also made projection formulas that relate the structure of sugar to one or the other of the two enantiomeric forms of glyceraldehyde. These projection formulas represent three-dimensional stereoisomers. So, dalawa no, two type. Emil Fischer actually produced two types of projection formulas or three-dimensional formula para sa ating mga sugar. Each carbohydrate isomer has a different shape and reacts differently in biological systems. In Fischer projection formula, the molecule is represented with the aldehyde or ketone group on the top. Tandaan, kapag nagsusulat kayo class ng Fischer projection formula, always na ilalagay ninyo ang aldehyde or ketone group on top, okay, on top of the structure. The hydrogen and hydroxide groups attached to the interior carbons are written to the right or to the left as they are projected towards the observer. Sige, i-compare natin ang three-dimensional representation ni Fischer sa kanyang projection formula. This is the three-dimensional representation. Ang carbon atom is ang symbol ng carbon atom is the circle. Okay? And then when you say projecting towards the observer, etong dalawa na ito, left and right. And then when you say projecting away from the observer, yung vertical lines natin, which is these two. Okay, yung mga dot, yan sila, vertical lines away from the observer, horizontal line naman towards the observer, meaning papunta sa tumitingin at papuntang likod, no? Okay, so ito ang three-dimensional. So tingnan nyo sa three-dimensional, ang aldose and ketone group is found on top of the vertical line. The alcohol group is found on the bottom of the vertical line, meaning itong aldehyde group na ito at itong alcohol na ito is projecting away from the observer. The hydrogen and hydroxyl group naman are projecting in the horizontal line, so meaning papunta sa atin, sa viewer. So paano mo yan siya ngayon gawing Fischer projection formula? There are two types of Fischer projection formula class. The first one is still showing the carbon atoms in between. And the second one is much easier kasi nga hindi niya na pinapakita yung carbon atom. The cross, no? The center of the cross signifies the presence of the carbon atom. So, on the first one, so sinulat niya muna yung tatlong carbon atoms. And then, on top of the carbon or on top of the vertical line, nilagay niya ang aldehyde group. Sa third carbon naman natin, at the bottom of the vertical line, nilagay ang alcohol group. And then, sa second carbon, andoon na naka-vertical line, naka-horizontal line, ang hydrogen and hydroxyl group. So, in a simpler way, hindi niya na sinulat yung carbon sa gitna, so naging cross na lang dito. Okay? So, in our quizzes class and examination, I prefer for you to use these two. Okay? Depende na lang sa inyo kung saan ang gagamitin niyo. Pero both of these I will accept. Okay? And please pala class, remember, when you are writing the projection formula, always write the lines properly. Parati ninyong i-direct yung line doon sa carbon atom, or always point the line on the very first element, doon sa pinakaunang atom na makikita sa formula. For example, ito, CH2OH. Paano kapag, for example, ang answer ninyo ganyan? So, sinulat ninyo yung linya, pero yung linya nakadugtong sa hydrogen, hindi sa carbon atom. This is wrong. Okay? Always mong itansya yung linya mo doon sa pinakaunang letter ng compound. Hindi sa pangalawa, hindi sa pangatlo, at hindi sa panghuli. Ako ha? Kapag may ganito, maliin ko yan. Okay? Dapat, dali lang. Sana tayo. Dapat sakto. Okay? Katulad nito. Yan. Sakto. Carbon to carbon. Sa carbon ka, kasi siya ang pinakaunang atom in the molecule. Kuha? Dito naman, so, ang linya is dapat sa, depende na lang kung nasa right ang OH ninyo or nasa left. So, always dapat carbon to oxygen. Okay? Kapag hydroxyl group, dapat carbon to oxygen, hindi carbon to hydrogen. Oha? So, dapat itansya ninyo na sakto yung linya ninyo doon sa inyong ididikit. For example, sige. In the three-dimensional structure, the hydrogen and hydroxyl groups projected towards the observer, and the CHO and CH2OH groups project backward, away from the observer. Any two monosaccharides that differ only in one configuration around a single carbon atom is called epimer or epimers. Therefore, D and L glyceraldehyde are epimers. So, sabi niya, ito ang D-glyceraldehyde natin. Kasi ang kanyang hydroxide group is found on the, or hydroxyl group is found on the right. Ito naman ang L-glyceraldehyde because its hydroxyl group is found on the left. So, di ba, pareho sila talaga ng structure. Pero nagkaiba lang sila sa isang carbon lang. Sa second carbon, kasi ang D-glyceraldehyde nasa right ang hydroxide or hydroxyl group, ang L-glyceraldehyde naman nasa left ang hydroxyl group. So when you have types of isomers class, ang tawag sa kanila is epimers. Okay? Any two monosaccharides that differ only in the configuration of hydrogen and hydroxide group in a single carbon atom. In this case, in carbon number 2, you will call that as epimers. So, ang L and D glyceraldehyde natin, they are epimers. Sige. Fischer recognized the two enantiomeric structures of glucose assigned the names as follow. You have your D-glucose and L-glucose. D-glucose ito kasi ang kanyang hydroxyl group is found on the right. Sa carbon number 5 niya, ang kanyang hydroxyl group is found on the right. So, you can write two types of projection formula. Yung isa, pinapakita pa yung carbon atoms. Yung isa naman, gumamit lang ng purely linya. Uha? Okay, how about the other one? It's an L-glucose because the hydroxyl group is found on carbon number 5 is found on the left side. Now, kung tingnan ninyo, pareho ang structure ng D-glucose and L-glucose, correct? Pero magkaiba lang sila ng configuration or position of the hydrogen and hydroxyl ions on carbon number 5. Therefore, D-glucose and L-glucose are both epimers. Okay? So, si Fischer, gumawa siya ng parang family tree ng ating mga they call this sugars, coming from the simplest types of aldose, which is the triose. Ito siya, your glyceraldehyde, D-glyceraldehyde. So, CHO, tatlong nanggaling sa glyceraldehyde na may tatlong carbon, papuntang uh, tetroses, which contains 4 carbons, papuntang pentoses, which contains 5 carbon atoms, hanggang sa pinakahuli, hexoses, na merong 6 na carbon atoms in the structure. So, pinakita dito sa sample natin, class, ito ang D family of aldoses. Meaning, aldose sila that has, they are aldoses kung saan ang kanilang hydroxyl group is found on the right. Ito lahat sila aldoses because they have the CHO structure on carbon number 1. So, mga aldose ito, okay? Coming from 3 carbon atoms, 4 carbon atoms, 5 carbon atoms, and 6 carbon atoms. So, D itong lahat kasi nga ang kanilang hydroxide group is found on the right. Okay? Yung OH group nila. So, how will you produce all of they call this the aldoses coming from your D-glyceraldehyde? So, ito ang nangyayari. Sabi niya, the D-glucose has the OH group in the right in the carbon number 5 next to the terminal primary alcohol, which is the same in D-glyceraldehyde in carbon number 2, while L-glucose, sige mamaya na yan, nahin ko muna ito. Okay, nanggaling dito, class, sa D-glyceraldehyde. Tatlong carbon atoms, and then ang hydroxyl group is found on the right. How will you produce tetroses from your trioses or trioses? So, mag-add ka lang ng isang carbon. So, ang gawin mo, dalawa sila. Okay? 2 types. The first carbon will always contain the CHO group or the aldehyde group. So, CHO, CHO. So, coming from tatlong carbon, so isulat mo na 4 na carbon na sila. Okay? And then, yung naunang group natin ng hydrogen and hydroxyl group will remain. So, parehong position muna. Okay? Dagdagan mo lang ng isa on top of it. So, CH2OH, kopyahin mo yan. Kopyahin mo rin itong nauna galing sa glyceraldehyde. So, H and OH. So, dinagdagan mo siya ng isa para maging tetro siya. Okay? Makakaproduce ka ng dalawa. Yung unang structure mo is D-erythrose kapag nilagay mo ang hydrogen on the left and hydroxide on the right. Makakaproduce ka naman ng D-threose if nilagay mo ang hydroxyl group naman on the left and hydrogen naman to the right. Kuha. So, pareho lahat, tinake home mo, pareho yung structure sa glyceraldehyde, nagdagdag ka lang ng isa pang carbon. So, kapag nagdagdag ka ng isang carbon, ang isang form niya, mauna ang hydrogen sa left side, right naman ang hydroxyl. Sa pangalawang form niya, ang hydroxyl naman ang sa left, and ang hydrogen ang sa right. So, you will name the structures formed as D-erythrose. So, parehong hydrogen ang nasa left side, parehong hydroxyl group ang nasa right side. Makakaproduce ka naman ng D-erythrose, D-threose, okay? If sa second carbon mo, ang OH mo is nasa left side, ang hydrogen is ang nasa right. So, binaliktad mo lang. Sa left side, parehong hydrogen ang nasa left side. Dito naman sa right side, binaliktad mo. Kuha. So, yan ang ating dalawang tetroses, okay, of the aldose group or D-aldose group. So, pareho silang D. Kasi, ang kanilang carbon atom adjacent to the alcohol, ang OH group, nasa right side pareho pa rin. So, D and D pa rin silang dalawa. Now, how will we produce pentoses naman from your tetroses? So, ganun pa rin. Each structure will produce two offsprings or baka produce siya ng dalawa pang structure. Ang kuha, dito isa lang siya, dalawang structure ang na-produce niya. Dito, since may dalawa kang structure, apat na structure ang mapoproduce mo for pentoses. Sige, unahin natin ang D-erythrose. So, kopyahin mo lang ang structure ng D-erythrose pero magdagdag ka ng isa pang carbon atom. So, kopyahin mo ang CHO on top and CHO on top. Magdagdag ka sa baba niya ng another additional carbon atom and then kopyahin mo na lang yung natirang structure ng erythrose mo. So, dito, 'di ba? Pareho lang itong structure na ito dito sa structure na ito. So parehong HHOH CH2. Dito rin pareho din HHOH CH2. Magkaiba lang sila sa carbon number 2. Kuha, yung sa isa mong dinagdag na carbon, ginaya mo na nasa left side ang hydrogen, nasa right side ang hydroxide. Pagdating sa pangalawa, binaliktad mo na yung OH. So, OH and hydrogen. Akuha. So, pareho silang D because ang kanilang hydroxide group is found on the right. Dito sa ating carbon number 4. So, D-ribose ito, D-arabinose naman ito. And these two are epimers. Akuha. Epimers sila kasi pareho sila lahat ng structure maliban lang sa carbon number 2 nila. Okay? Sige. Let's go with D-threose forming 2 pentoses. Kopyahin ang structure ng D-threose. So, CHO, dagdag ng isang carbon. Ang isang carbon mo will, the first carbon in the first group, ang kanyang hydrogen is sa left, sa right naman ng hydroxyl group. Dito sa kabila, ang carbon number 2 mo, baliktad. OH ang sa left, H ang sa right. And then, copy na lang the rest of the structure of the threose. You will produce D-xylose and D-lysose. Okay? And then, how will you produce hexoses galing sa pentoses mo? Since may apat ka na pentoses, ilang hexoses ang ma-produce? 8 na hexoses kasi dalawa-dalawa. So, D-ribose will produce D-allose and D-altrose. The same process pa rin. Kopyahin lang ang CHO, and then mag-add ka ng isang carbon dito. Ang isang carbon, H ang sa left, hydroxyl ang sa right. Sa kabilang group, ang hydroxyl mo baliktad, nasa left, ang hydrogen ang nasa right. And then copy na lang the rest of the structure of your ribose. You will produce D-allose and D-altrose. And the other products class, ito na ang different types of hexoses natin. You have your D-allose, D-altrose, D-glucose, D-mannose, D-gulose, D-idose, D-galactose, and D-talose. Ako ha. So, ang dalawa, glucose and galactose, these two are the most used by the organic system. The D-glucose has the group, hydroxyl group on the, okay, I think tapos ko na yan na-explain. Diretso tayo dito. In the D configuration of aldoses, in figure 2, ito sila, you can see that all have the hydroxyl groups in the right, in the carbon next to the terminal primary alcohol. Diba? Lahat sila. Ito ang primary alcohol natin. Lahat ng carbon na next, ang kanilang hydroxide or hydroxyl group is found on the right talaga. Kung tingnan ninyo. So, ito sila lahat. Ito ang D family class. D-aldose or D family of aldoses. In this family, new chiral carbon atoms are produced starting from triose to tetrose to pentose to hexose. A pair of epimers is made that differ only in carbon number 2 each time a new chiral carbon atom is added. For example, D-erythrose and D-threose are epimers. lahat ng kambal dyan, mga epimer, yan sila. Itong dalawang to, epimer. Itong dalawang ito, epimer. Itong dalawang ito, epimer. Lahat ng magpartner. Itong dalawa na ito, epimers din, epimers, and epimers. They will differ only in carbon number 2. Okay? For example, ayan, can you name the other pair of epimers? The 8 aldohexoses are produced when the sequence is continued. Always remember that the number of stereoisomers follow the formula 2n. The aldohexoses have a total of 16 structures. Can you draw the L structure? Okay. Ito siya, class. Aldohexose sila, di ba? Pero ito lang yung D family. D family lang sila. Meron ka pang L family. Ang L family natin naman, pareho lang, pero ang kanyang OH group, galing sa glyceraldehyde niya, L-glyceraldehyde, ang OH group niya nasa left side, ang hydrogen nasa right side. So, coming from an L-glyceraldehyde, makaproduce ka pa ng lahat ng ito, pero lahat sila L naman. So, dapat meron ding L-erythrose, L-threose, L-ribose, L-arabinose, L-xylose, L-lysose, diba? Kasi ito, example ito is, ano lang man siya. This is just an example of the D version or D isomer. So, meaning lahat ito sila may kakambal pa sila na L isomer. So, diba, ang final product natin, 8 na D aldoses. So, meron pa siyang kambal na another 8 L aldoses. So, in total, 16. Kasi ilan ba ang chiral carbon atoms na makita mo sa hexose na structure? 'Di ba? 4. 4 sila. So, therefore, 4 to the power of 2 will yield 16. A total of, ayan always remember that the number of stereoisomers follow the formula 2n. The aldohexoses have a total of 16 structures. 8 doon is D, 8 naman doon is L. Kuha? So, 2 to the power of 4. Makakuha ka ng 16. 'Di ba? So, the conversion of your aldose, ayan. Punta na tayo sa Killiani or Killiani-Fischer synthesis. Okay, always remember, class, ha. Sandali lang, nag-break lang si ma'am, nag-water break. Okay, refresh tayo. Always remember that the formula for finding the total number of stereoisomers is 2n. So, in a hexose, okay, hexose sugar, ilan ang chiral carbon atoms? Diba? 4. So, meaning 2 to the power of 4, you will get a total of 16 isomers. So, itong pinakita dito sa inyo na 8 D aldose, 8 pa lang yan sila. Meron pang another 8 para sa L family naman ng aldoses. So, if gawin ninyo siya, parang practice lang, no, you can do it. Gayahin lang itong ganito na process. The only difference is that L-glyceraldehyde ang pangalan niya, and then ang OH nandito sa right, ang hydrogen naman ang OH nasa left, and ang hydrogen naman nasa right. So, follow lang yung process, makukuha nyo yung 8 naman na L family of aldoses. So, ganun pa rin ang pangalan nila. Ang nagbago lang is hindi letter D ang nakalagay, letter L. So, L-allose, L-altrose, L-glucose, L-mannose, L-glucose, and so on and so forth. Okay? Now, how will we produce this? Paano ito ginagawa? How will you produce hexoses or how will you convert your trioses to tetroses to pentoses and hexoses in the laboratory? By using your Killiani-Fischer synthesis. So, nag-combine si Killiani at saka si Fischer to produce this synthesis. This synthesis involves 3 steps, okay, in order to convert your sugars. Number 1, you will add your hydrogen cyanide, okay, to form cyanohydrin nitrile group. So, if ito yung inyong sample, ayan, ito ang inyong D-glyceraldehyde. So, i-convert mo siya ngayon sa isang tetrose. Kasi ito, triose man ito, tatlong carbon. I-convert mo siya into tetrose containing 4 carbons. In order to do that, you will add hydrogen cyanide sa inyong sugar D-glyceraldehyde to produce these structures. Dalawang structure pa rin containing CN on top. Your CN is called cyanohydrin nitrile group. Cyanohydrin, ang spelling ng nitrile is N-I-T-R-I-L-E tapos group. Ito sila ang CN dyan, yung cyanohydrin nitrile group. Okay, after mo nakaproduce ng structure containing your CN, magkakaroon ng hydrolysis with the use of your water and hydrogen atoms, okay, to convert the cyanohydrin nitrile group into COOH. So, from CN, na-convert siya into COOH, okay? And after that, you will reduce, okay? Magkaroon ng reaction when you will add sodium amalgam or this one, NaHG, doon sa inyong COH group. Ang mangyayari, ma-convert ang COOH into aldehyde group. So, from COOH, naging HCO siya. Therefore, producing a tetrose or tetroses sugars like your D-erythrose and D-threose. So, ito yung ginagawa inside the laboratory. Following the steps of Kiliani-Fisher synthesis, write the reaction to produce 2 aldoheptoses using D-glucose. Sige, ibigay ko sa na lang, sa activity ninyo. We will do this in your activity. Okay, that is the end of our first part, no? The first part of the discussion of the first half of chapter number 3. Kasi nga, hinati natin yung chapter number 3 and then hatiin ko rin into 2 video discussions. So, thank you for watching. I hope na you will try the practice test, no, na nakalagay dito sa chapter na sa first part na ito so that when I give you the activity, alam nyo na kung paano sagutin. Thank you for watching. I hope you took the time to write down your notes. See you on our next video class. Good luck and bye.